Hello and welcome to the webinar on Urbano Hydra. My name is Michael Vajc and I will be your host today. So, Studio Ars develops several software for infrastructure pipe networks. So this is Urbano Ultimate, it's a full package. Then Urbano Canalis for sewage, Urbano Hydra for water, and Urbano Gasnet for gas distribution systems. Today we'll be focusing on Urbano Hydra for water distribution design. So when we talk about Urbano software, we emphasize that it's a design, calculation, and analysis of infrastructure pipe networks. We have more than 30 years of development in this field, and we focus on pipe networks. In this time, we have developed very distinct functions and workflows, especially for designing pipe networks like sewage and water. We have a lot of engagement with our users, and a lot of our development is based on this feedback from the users and engagement with them. Specifically, when we talk about Hydra, so our solution for water network design, we emphasize that it's a solution for design in plane and profiles or long sections. Also, for the calculation and optimization of networks, we are using the IPANET engine. It's built into the software, so you don't need to have it separately installed. Urbano Hydra is also great for analyzing your network, and you can do this with various styles and labels, data tables, queries, and many other functions. Urbano Hydra is also great at connecting to other workflows because it's very easy to connect to various GIS or design software, also hydraulic modeling software, and also to various BIM workflows through the IFC and the Navisworks exports. And last but not least, Urbano Hydra can be customized, so you can customize a lot of functions, catalogs, even the user interface. Okay, so without further ado, let's jump into the live presentation. Rino, please take over.
Thank you, Michael, for your introduction. Hi and hello to everyone. My name is Rino and welcome to another Studio Ars Urbano webinar. Today's topic will be Urbano Hydra, our software for water distribution network design, analysis, and hydraulic calculation. In the following 50 minutes of live presentation, I will show you full workflow from the creation of the network in plan and profiles to hydraulic calculation and exporting of 3D BIM model to Navisworks. So let's start with the live presentation. As you can see here in this drawing, I basically have just this raster image of this area where we are going to design this water distribution network. But in Urbano, even if you don't have a raster image, you can always download it directly from Google Maps service. So let's go to Tools. Let's go to Import from Google Maps. And here I will just simply start searching for the area. The place is called Novi Vinodolski in Croatia. So just start typing. Google finds this area. And now we can precisely define the zoom factor and the position of the map, for example, like this. And now I will just select this area. I can define what I would like to import. Is it just a raster, just 3D points with elevations, or both? Let's select both. And also let's define coordinate system to be this Croatian coordinate system zone 5. Let's click import. And now in a matter of seconds, we will get this raster image directly from Google service and as well these 3D points with elevations. So this is done. Let's now check this raster image first. You can see that it perfectly fits this map that we had from before. You can see how this roads continues on the edges of the map. So the coordinates are precise. Also, let's switch to 3D view. So we can focus on these 3D points with elevations that we downloaded also. So you can see the points. We can check in the AutoCAD properties. it is 2500 points because that's the resolution that we defined, and each point has its own elevation. So with these points you can easily create DTM surface either by using Civil 3D or by using Urbano Terraform. So when we talk about DTM in Urbano, it's up to you. If you run Urbano on top of Civil 3D, you can use Civil 3D DTM surfaces, and if you run Urbano on top of plain AutoCAD, you can always use our own DTM modeler Urbano Terraform. So let's go back to plan view, and I will switch to a different layer state because I will not use this 3D points that I downloaded from the Google service, because I have much more detailed and much more precise surveying data that I already used to create two DTM surfaces. One is this Civil 3D DTM surface. You can check it. You can see this is Civil 3D thin surface. And also I use the same surveying data to create Urbano Terraform surface. So I will just now apply the styling to show you that the surfaces are basically identical. You can see that these triangles are identical. So it's up to you if you want to use Civil 3D DTM surfaces or our own Urbano Terraform surfaces. Okay, let's now again switch to a different layer state, and let's talk about network design. So this will be our water distribution network. Here it will be a water tank. Then we will have a pipeline from the tank to the distribution network. And here we will convert this plain AutoCAD 2D polylines to Urbano intelligent topology. So let's now do this. When we talk about drawing the network in Urbano, we have three main ways. First way is by interactively drawing in plan. Second way is by conversion of AutoCAD elements such as 2D lines or lines with elevations, or 2D or 3D polylines. And the third way would be by importing from some kind of external file source, which can be, for example, EPANET EMP file, SRE file, LandXML, various SQL databases, and so on. So first of all, let's start the first command for drawing. And here you can see that you can define many different options and parameters here. For example, we can automatically label the nodes and the sections with some of the predefined label configurations. We can automatically set pipes from the pipe catalog. I will use PEHD pipes with nominal diameter 315 for this transport pipeline. And also you can automatically set terrain elevations from selected DTM surface. I will use Civil 3D DTM surface, but also you can use Terraform as well. And I will place the center line of the pipe to be on a constant depth below terrain of 1.5 meters. So let's click on draw. And now I will use plain AutoCAD OSNAP functionality to snap to the centers of these helping circles. And you can see that how I am picking, these labels are automatically appearing both for the nodes and for the sections. For the sections we see lengths, nominal diameters and materials, and also for the nodes we can see terrain elevations and invert elevations or centerline elevations that came directly from the Civil 3D DTM surface. So let's continue here to the last node of this system, and let's now switch to second command to convert these AutoCAD polylines to Urbano network. So let's open the function for conversion of CAD elements, where you can see that you can set up all the same options as before. So we will again use Civil 3D DTM surface. For the pipe from the pipe catalog, I will select the same catalog bit, but with a smaller pipe. Also, we will set constant depth below terrain for a center line to be 1.5 meters below the terrain, and we will use the same label configurations. Also here we have one really nice option for layer filtering. You can just select a layer from the network, from the plan. For example, I will select this element here, or you can do it from the list, and the software recognizes which layer this is, and now you can freely select the entire drawing, and the software will select just those elements on selected layer. And now when we click on convert, everything will be converted from plain AutoCAD polylines to intelligent Urbano topology consisting of nodes and sections. Okay, let's now turn off these helping layers. We don't need them anymore, and let's focus just on the Urbano network. So the best way to analyze Urbano network is always by using Urbano data tables. So here on the left, you can see that you can have different configurations of these data previews with different data inside. So if you want to use it, we can open these data tables. Now you can choose which configuration of the data you would like to check. For example, let's select section geometry. And now you can select the entire network and preview the entire network. Or you can use these intelligent selection options to select just some parts of the network. For example, let's use selection of sections, and let's select just few sections from the drawing. Let's select these 3 sections. Okay, and now we can see in the data table just those 3 sections selected. But also in Urbano, we have much more intelligent selection options. For example, from node to node, branches and arrays. So let's check what is a branch in Urbano. So basically, a branch in Urbano is something in between 2 main nodes. So basically in between branching of the system. And if you select a branch, for example, let's select these 3 branches, we will get all the sections that belong to these branches. But also if you switch to a different data configuration, let's say branch geometry, you will get the group data for the entire branches. Also in Urbano, we have something that we call arrays. Arrays are basically the original polylines that we converted from AutoCAD, but also these arrays can be edited. You can merge them, you can break them, and basically create your own topological elements. So if you select, for example, these 2 arrays, you will get all the sections and also all the branches that belong to these arrays. And also you can switch to, again, different preview configuration, for example, array geometry, and then check the group data for the entire arrays. Okay, let's now edit these arrays a little bit. Let's open the function for array editing. And first of all, I would like to merge these 2 arrays. So let's go to selection of arrays. I will select this one and this one, and I will give it a new name to be A1. Let's click apply. Then I will go to function for automatic renaming of the arrays, and I will select these 4 horizontal arrays, and I will give it a prefix of H with the counter from 1 to 4. Let's apply. Then I will select these 4 vertical ones, and I will give it a prefix of V like vertical from 1 to 4, and I will click apply. Okay, let's now open this data table again. Let's select the entire drawing. And now if I sort it by arrays, we can see array A1, H1 to 4, and V1 to 4. Why these selections and this topology is so important, you will see during this presentation. So first of all, these selections enables you to quickly and easily select a lot of elements at once and do many different operations really quickly. One of these functions is function for drawing of the profiles. So just like for the data previews, for the profiles, you can also have multiple different configuration with different data, different language, different scale, and so on. So to draw profiles, just select the configuration with which you would like to draw, and then you have your selection options. You can draw it by branches, by arrays, from node to node, or we can select the entire network and say, draw all the profiles by array or branch topology. I will go by arrays. Let's define number of rows to be 5, number of columns to be 2, and let's draw these 9 profiles with just one click of a mouse, and let's place it here. Okay, so this is one really easy and quick way to draw profiles. Another way is by going to function from node to node, where you can basically select any node and go to any node in any direction. I will go through this node all up to the last node of the system, and I will draw this profile here. So you can see how it is easy and quick to draw profiles in Urbano by the topology elements that I showed you before. Now, if we check these profiles, you can see the terrain line in green color that came directly from Civil 3D DTM surface. You can see these pipes that we positioned on a constant depth below terrain. And also you can see all this data that are defined inside of these profile configurations. So if you want to edit something, for example, you would like to change some graphical part or some data here in the data table, it's really easy to edit. So just right click, edit. And now because there is a lot of data that can be changed, we have this really nice tool, which is called Interactive Select, which enables you to select any part of the profile, graphical or numerical. For example, I will select this terrain line, and the software will take me where this data can be changed. So let's change the color of terrain from green to, let's say, this brownish color. Okay, and let's click apply. And now you can see this part of the profile has been changed. Let's change one more thing. For example, let's select this pipe. And now let's change, for example, this dashed invisible part of the pipe to continuous. And let's click OK. So it's that easy to change your profile configurations. And of course, you can store it, you can save it, and use it on all of your other projects. So we define this center line of the pipe to be on a constant depth below terrain. But also we have in Urbano many different functions which we can edit or draw this pipe position really precisely directly in the profiles. So there is also one really nice option which we can use for some kind of helping function. That function is drawing of auxiliary elements. And now with this function, I would like to draw terrain parallels. So I will select all the profiles and I will draw two terrain parallels, one 1 meter below terrain and the other one 3 meters below terrain. Let's click draw. And now you can see if we are maybe somewhere too deep or too shallow below the terrain. For example, in this part here, we can see that we are maybe too shallow because of this hump in the terrain. So maybe we can edit this pipe position to be a little bit more down. So of course, we can open these data tables again. We can switch to section geometry. We can select this profile or part of the profile, and then using this data table, because these data tables are not just for previewing, you can use it for editing as well. You can just start typing and editing, starting or ending invert elevation of the pipe. But like I said, we have much more better intelligent ways to do it. And one of these functions is the function for input or edit pipe position directly in the profile. And here you can select the entire profile, or for example, from node to node in profile. Let's go, for example, to this node here. And now you can define starting or ending depth or elevation, or we can straighten this pipe by slope. Let's define a constant slope of -5 per miles. Let's preview it to check how it will look like. So if you're satisfied, just click on apply. Now notice how the Urbano model is completely dynamic. All the data have changed in the data table. Now we have straight pipe here in this part of the profile, and also the data table of the profile automatically updated. So we have this -5 per miles. And let's now fix this problem here. Let's go, for example, from this node to this node. And now in this last node, I would like to increase the depth a little bit. So from 1.5, I will increase it to 2. Okay, let's preview it. Let's apply it. And now you can see how we successfully resolved this issue here. Also, in the same way, we can go through other profiles and check if everything is okay. So let's say that this is our final solution for our pipe positions. So I will delete these helping lines, these terrain parallels now. So the following task would be to automatically set air release and washout valves. To do that, I will go to Hydra panel, and here we have a function for air release and washout valves. So we can do this interactively by selecting single nodes and defining them to be air release or washout valves, or we can do it automatically by selecting the entire network and just click on apply. So this function is basically searching for the highest and the lowest inflection points of your network. For example, here. So basically where the slope is changing from negative to positive or from positive to negative, and it automatically places this air release and washout valves. Also, if we turn on this auto zoom function, and if we pick, for example, on this air release valve, you will see that the software is automatically placing these custom blocks not only in the profiles, but in the plan as well. Okay, let's now define manholes as well. So let's go to function for setting of the manholes. Here from the manhole catalog, you can choose any type of the manhole. In the manhole catalog, you can define different shapes of the manhole, different sizes, different materials, and so on. I will use this rectangular manhole with rectangular open with this size. You can also define some parameters, and then you have your selection options. I will not select the entire system. I will select just these nodes where I have this branching in my network. Of course, you don't have to set the manholes. It's not essential for your model, but if you need the manholes, you can always set them to some nodes, because not every node in Urbano is automatically manhole. So let's now save the manholes to these branching nodes. Let's go to our profiles. And now here you can see again the dynamic model of Urbano. The manhole automatically appeared everywhere in the profile where we define the manhole to be. Let's also place this air release and washout valves to be inside of a manhole as well. So now I will select the entire system, but I will use node type filtering. So I will select just the nodes with the air release valves, and I will click save. Notice how the profile in the profile the manhole will appear, and also let's repeat it for washout valves, and let's click save. So now we have defined the manholes everywhere we would like them to be. And now let's switch to plan. And you can see that in the plan, nothing have changed automatically. And that is because I have the default style applied. So by default, these plan styles, the pipes or the sections are plain AutoCAD lines, and the nodes or the manholes are by default some custom blocks. Of course, you can change them. But if you want to have the real dimensions of manholes and pipes, you can always apply the 2D style like this. And now you see the real dimensions of these pipes and manholes. Of course, where we didn't set a manhole, this block will still appear here, but of course you can put a point as well. So let's also apply 3D style, which is basically the application of 3D solid elements, AutoCAD solid elements. So if we switch to 3D view, now you can see all of the networks of these pipes and manholes in 3D. And it is important to say that even though these are AutoCAD 3D solid elements, this is still live model. So for example, if you increase or decrease the pipe diameter, the 3D model will automatically update, and the same goes for the manholes. So let's go back to plan view now, and I will apply back the 2D style because I think that this is the best plan style to have while designing your network. Okay, so at this point, I would like to switch to a different drawing, which is basically this same project, but in a little bit later stage of the project. I just predefined some stuff so we can move a little bit faster through this presentation. So in this part of the presentation, we are going to set a water tank, define water demands, and run hydraulic calculation. So let's go to the first node of this system, and let's define it to be a water tank. Let's switch to Hydra panel, hydraulic node equipment function. Let's select this first node, and from the drop-down list, I will select a water tank. You can see that here you have all the EPANET available equipment, such as reservoirs, tanks, emitters, valves, and pumps. It is important to say that Urbano Hydra uses EPANET engine for hydraulic calculation. So let's select this to be a tank. You can also define all of the tank settings, but I will leave everything as default, and let's click apply. Notice how the block automatically changed and appear both in plan and in the profile as well. Okay, so now that the water tank is set, let's also define water demands. So to define water demands in Urbano Hydra, you can use one of many different methods that are available here. For example, one of these methods is, as we call it, percent calculation, where you basically define water consumption per inhabitant per day. Let's define it, for example, 180 liters per day per one inhabitant. Let's define number of inhabitants, so let's say 5,000, and we have to define it for which part of the network. By default, the whole network is selected, but let's say this will be our transport pipeline, and I would like to set my water demands just for, let's say, this area here. As you can see, you can always use AutoCAD selection in Urbano as well. So I will select these parameters on this part of the network. So let's click right and let's check how this calculation works. So basically the software calculated maximum demand per hour in liters per second and also specific demand in liters per second per 1 meter of the network. And then this flow is distributed to the junctions. Okay, and of course we have the classic standard EPANET ways how you can define water demands. So basically point demands, just select the nodes where you would like to define some water demands. But unlike in EPANET, you can automatically set the same value, let's say 5 liters per second, to all the selected nodes. So let's just click on right. Or we can reset this and go through data table and just define, let's say, different value for different nodes. You have your data table and you have the marking of those nodes in the plan. I will again reset it and I will select just one node. Let's say that we will have here some kind of industry and I will define this to be 6 liters per second. Of course, you can create any amount of this, let's say, water consumption categories or configurations. So this will be our main water demand to perform hydraulic calculation. Of course, if these methods are not good enough for you, if you want to calculate it somewhat differently, you can always import it, let's say, from Excel or from plain text file. Okay, so all the demands are now set. Let's now go to hydraulic calculation. And like I said, Urbano Hydra uses EPANET engine for calculation. So if you go to options, you can see the all EPANET options like hydraulics options, times options, energy options. We will keep it simple and we will have snapshot hydraulic calculation with no time analysis. But of course, you can define the time patterns. You can run complete time simulation as well. Okay, so let's calculate it and let's save the results. That's it. So let's now check the results. You can immediately see how the profiles automatically updated, but I will also redraw them for these frames to expand as well, because now we have these piezometric lines automatically appearing, showing us the total head elevations for each node. Okay, so let's also check this hydraulic data in our labels. So now I would like to apply some different types of the labels. And just like for the profiles and for the data tables, the same is for the labels. You can have many different configurations with, let's say, different data. So for the sections, I will apply this length, diameter, flow, and velocity to the entire system. And for the nodes, I will select name, demand, head, and pressure. And you can see how it's really easy to change the configuration of the labels. And now we have these hydraulic values in our labels. Let's also check this data using our data tables, but let's switch from section geometry to section hydraulics. And let's select, for example, just this one array here. Let's use marking plan and zoom to plan options. And now you can see how I am picking through this data table. We can simultaneously see this data both in plan, in the labels, and in the data table as well. So you can see your standard section data like flows and velocities and diameters, but also you can see for each section starting and ending pressures as well. Okay, let's now turn off auto zoom. Let's zoom out a little bit and let's focus on the entire network. So let's select the entire network and let's sort it by velocities. So if you remember from the start of the presentation, I pretty roughly defined the pipe diameters. Here I set everywhere to be 315, so up to this point. And in this, let's say, distribution network, I set everywhere to be 160 millimeters. So of course, the results will not be optimal. So let's check the velocities. And you can see that the software is automatically marking some, let's say, too low velocities by some ranges. Of course, these ranges can be set up by the user, but by default, the software is marking in red all the velocities smaller than 0.1 meter per second. And you can see that we have a lot of these very small velocities. Also, if we check the highest velocities, you can see that we have some really high velocities, higher than 1 meter per second in this part of the network here. Another great way how you can analyze these hydraulic values is by using theme maps. So let's now apply one theme map for velocities for the sections. Let's select the entire network and let's just click show. And now with these different colors, we can see these color ranges. Of course, these ranges can be set up by the user as well. And now we can see in different colors where we have sections with lower velocities and also where we have sections with higher velocities. Also, what we can do is use queries to analyze results. Here I prepare some queries. Of course, you can create these simple queries like, let's say, velocities smaller or higher than some value. Let's, for example, use this one, velocity smaller than 0.5 meters per second. Just take it, drag and drop it, and place it in your data table. And now you can see that we have just the sections with the velocity smaller than 0.5, which is pretty much everywhere in this bottom part of the network. But also you can create much more complex queries using, for example, OR option or combining multiple data. For example, I defined here diameter between 100 and 300 millimeter with the velocities higher than 0.9 meter per second. So let's drag and drop it. Let's place it here. And now we can see that these velocities, that pretty high velocities, are in this part of the network here. Of course, what we could do now, we could just go to the function for setting of the pipes from the pipe catalog and manually increase these pipe diameters. Or, for example, I can go directly from the data table, right mouse button and edit. And this same function will open and I can manually increase the pipe diameter from the pipe catalog. But I would like to show you a little bit different workflow, and that is function for automatic sizing of the network. Let's delete first this theme map, okay? And let's go to Hydra panel, and the function is called pipe optimization or pipe sizing of the network. So let's open it, and this function works that you basically you can split your network in different, let's say, zones. So I previously defined two zones. First one is, I called it transport pipeline, and the second one is distribution network. For each zone, you can define target velocity. Target velocity can be defined by single value or diameter dependent. I selected diameter dependent, which means that the target velocity will depend on the resulting diameter. So of course, these ranges can be also set up by the user. And also for each group, you can define which pipes from the pipe catalog are available, which are allowed for that part of the network. And now all you have to do is click on start, and the software will optimize pipe diameters so that the real ending velocity is as close as possible to the defined target velocity. So before saving, you can preview your results. For example, we can also use our selection options, and let's select this main transport array. And now you can see inside of the brackets, you can see the new values, and in front of the brackets, you can see the old values. And you can see that in this part of the network, the software automatically increased the pipe diameter because this one were too small. So let's now save the results. And also you can check now the ending diameters, flows, velocities, and also these were the target velocities that we defined, so 0.8 for this part of the network, and based on the ending diameters. And you can see that the real velocities are really close to these target ones. So this is the difference between the real and target velocity. So let's now close this and let's analyze our results again. Let's now again start these team maps for velocity. Let's select the entire system. Let's show it. And now you can see that this looks much better. We don't have any more those red and dark orange colors. And you can see that the color ranges are now changed. Also, if we open our data tables, you can see the same area that we had before. Now you can see that the diameters are bigger and the velocities are smaller. And if we select the entire network, again, sorted by velocities, of course, we still have some really small velocities, but you can see these are on the ending parts of this branch network. So this is something that we can allow. And of course, we can see that now the highest velocity is in this section here, 0.83. Okay, let's now also check the results for our nodes. So let's switch to node hydraulics. Let's select the entire network and let's sort it by pressures. We can see that we have some really small pressures, again, marked in red, that are smaller than 25. And we can see that these nodes are here close to the water tank, basically where we don't have the water demands defined. So this is not a problem. But if we check the highest pressures in the network, we can see that the highest pressures marked in red that are higher than 70 are in this bottom part of the network. Okay, we can also apply one team map for the nodes as well. So let's select for the nodes team map for pressure. Let's select the entire network and let's apply it. Okay, let's now split our screen so we can simultaneously see this legend, and also this plan. And now again, in different colors, we can see places with the higher pressures and places with the lower pressures. Another great way how you can analyze your pressures is by using function for drawing contours. I will draw one contour with this. I predefined this configuration with these color ranges to match this legend of a team map. So now if I click on draw, you can see that we have again these color ranges, and we can see where we have the zone of higher pressures and the zones of smaller pressure, and it is matching this team map. So the logical conclusion would be to place one pressure reducing valve to this node here. Okay, let's go back to just one view. Let's delete the team maps. Let's delete the pressure contours. And let's again go to Hydra panel. Let's go to hydraulic node equipment. Let's select this node here and let's place it to be pressure reducing valve with the reduced pressure setting of 35 meters. Let's click apply. Now you can see that in the label, nothing have changed automatically. That's because we have to go to hydraulic calculation and just rerun the calculation. So calculate and save. And now you can see how the label automatically updated. Now we have this pressure drop to exactly 35 meters. And if we check our profiles, you can see this pressure drop in the piezometric line happening because of this pressure reducing valve that we defined in this node. Okay, let's now talk a little bit about water demand scenarios. I will again open the function for defining water demands, and I will add one more additional water demand for firefighting demand. So let's just select one node, or you can select multiple nodes, but I will select this one, and I will set here firefighting demand of 10 liters per second. Okay, like I said, you can create any amount of these water consumption categories, and then you can group them in different scenarios. So previously I created two scenarios. One is with firefighting demand. We can see all of our previously defined consumption categories, and one without firefighting demand. And now if we switch to scenario preview, we can basically run parallel hydraulic calculations for different scenarios, and we can see it in different colors. We can check it like this, all the results of one scenario and then all the results of another scenario. Or you can turn this option on, which I prefer, and you can basically compare it data by data, flows, velocities, hydraulic losses, and any other data that you put in the data table. Let's now use our selection options to select just this, let's say, area of interest, these two arrays. And like any other Urbano data table, you can select it, you can copy the content, you can go to, let's say, Excel or any other Microsoft application, and you can paste it and get one really nice report with all this data, and all these colors are also copied here to Excel. And we can see that for this red scenario, which is the scenario with firefighting demand, we have some higher velocities happening because of that firefighting demand that we defined. Okay, let's now go back to Urbano. Of course, what we could now do, we could go back to our pipe optimization and basically optimize our pipes for this bigger scenario. But we will not do that now. Again, we will switch to another drawing where I have some stuff already predefined. Not to be repetitive, I just converted one more additional polyline here, and I defined one reservoir here to this node, and I define one pump here to this node using our hydraulic node equipment function. Also for this pump, I define one pump curve for this water distribution network. And also if we check our profile, we can see this additional part is now here, and you can see these custom blocks for reservoir and for the pump. And now we have everything ready to rerun our hydraulic calculation. So let's go to hydraulic calculation. And now here under demands, you can see that we can define some of all defined demands or one of these scenarios. So let's select now scenario with firefighting demand, which is basically the same as sum of all defined demands. And let's click on calculate. I didn't say this before, but each time you click calculate in Urbano, this AppAnet EMP file is created. So to run hydraulic calculation with Hydra, you don't have to have AppAnet installed on your computer at all, because AppAnet engine is built inside Urbano Hydra. But if you have AppAnet installed on your computer, you can open the model in AppAnet directly from Urbano Hydra. And this is it, the exact same model with all the parameters, all the equipment, all the elevations from DTM, but defined in Hydra. So let's select, for example, this junction here. You can see the elevations that came from DTM. We can see these demand categories. We have inhabitants and industry. And also, for example, in this last node, you can see, again, inhabitants and firefighting demand. Let's go back to Hydra and let's save these results here. Okay, let's close this and let's check now the results. You can see that the profile automatically updated, and now you can see the piezometric lines also appearing for this part of the network. And because of the firefighting demand, we can see that we have this bigger pressure drop happening because of the higher velocities that we saw before. Okay, so now we are done with the hydraulic calculation part of the presentation. So I will again switch my layer states, and now we will switch to something completely different, and that is setting the trenches and calculating the trench excavation quantities. So let's go to input data, trenches, and let's define the trenches for this network. Again, just like for the pipes and for the manholes, in the trench catalog, you can define different types of trenches, different sizes, different angles, different shapes, different materials. I will use this single trench with sand bedding and with formwork with the angle of 90 degrees. Of course, I will select for the entire network the same type of the trench, but you can define different types of the trench for different parts of the network. Now let's go again to input data, and let's also define the top layers or upper layers of the trench. So I'll set first for the entire network from the top layer catalog 15 centimeters of asphalt. This is 2 layers of asphalt. and let's click Save. And then additionally, I will go with this function from station to station. So I don't have to go from node to node. In this function, I can go from station to station because we are not everywhere under a road, under an asphalt. So I will say from this point to the start of this system, like this, I will overwrite this asphalt with 2 layers of some earthy material. So let's click Save. Okay, and now let's check this in profile. So you can see how the profiles are automatically updating. You can see that we have this sand bedding automatically appear because of a defined trench. And you can see that up to this point, we have 2 layers of earth. And from this point on, we have 2 layers of asphalt. Also, if we check our profile table, we can see that now the data for the trench, like trench bottom elevation and depth, automatically appeared as well. So now that we have defined trenches and the top layers, let's also draw cross sections. So to draw cross sections, it's again extremely easy, just like drawing the profiles. You can have different configurations with different data, different scale, different colors and hatches and so on, and just select the configuration. I will use this in a larger scale, 20:1. And then I will go by arrays, but you can also select interactively stations in plan or in profile, or you can automatically draw it in some characteristic points of the network. For example, I will go automatically every 20 meters along these 2 arrays, like that. We can see in total this is 68 cross sections. I will define row and column spacing to be 10, and let's position these 68 cross sections here. So 68 cross sections have been drawn in a matter of seconds, and now we can check them, how they look like. We can see that they look really nice. For each cross section, you can see the station on an array, you can see nominal diameter of a pipe, and all of the cross-sectional areas of the trench. So total excavation area, bedding, pipe, backfill areas, and also the top layer areas. And also we can see this these parts where we have this earthy material on top, and also here we have these 2 layers of asphalt, and also you can see all these hatches, all these colors, and also you can see this formwork as well. And everything have been defined here inside of these configurations that you can of course store for your later projects. Okay, so now that we have everything defined, let's also run excavation report. So double click it. I will select the entire system. I will sort it by arrays, group it by arrays, and let's save it to Excel. So in a matter of seconds, Excel report will be created that we can open directly from the software, which is now. Let's open it. And now let's check it. So for each section, we have starting and ending station, total excavation volume for the entire section, excavation volumes according to depth excavation zones, which can be set up by the user. By default, it's from 0 to 2 meters, 2 meters to 4 meters, 4 meters to 6 meters, and so on. Then you can see the volumes of all of the top layers, so the earth and the asphalt layers that we define, and all of the layers of the backfill. So bedding volume, sand and ground backfill above the pipe, formwork area, and trench surface area. And the entire report is structured by arrays because that's how we defined it. And if we scroll to the bottom of it, we will see what is most important, and that is the total data for the entire system. So we can see total excavation volume and also total backfill volumes as well. Okay, let's now close this. Let's go back to Urbano. And now I would like to show you how you can quickly change your profile configurations. For example, for plotting. Before, I showed you how you can draw the profiles and how you can edit those profile configurations. Here I have multiple configurations. So let's say you have one configuration that is, for example, your design configuration. Then when you are designing for some other investor or another company or another country, you can have the configuration in different language or in different scale, or let's say prepared for plotting. And now using this profile manager, you can quickly just change the configuration with which some profile is drawn. So let's select this profile, and let's change the configuration from this default one to, let's say, this German one. This is a German standard. And now you can see all the data is in German. We have some different data. You can see the graphical elements look completely different. And also you can even have some data above the profile. For example, here we have the node schemes appearing on top of the profile. Also, let's now check another one. I will use this one, which is in much bigger scale. It is one-to-one with the plan. And now you can see again some hydraulic calculation values like flows, velocities, head losses. So different data, again, different visual style. It looks completely different, and it's that easy to change the configuration. And now I would like to switch to a final drawing today, where I have my, let's say, plotting configurations already prepared. So again, you can see some different data is here. The visual parts are again different. And to plot this to layout, first of all, we have to draw some helping frames. So let's start the function for drawing of the helping frames. We can select some of the profiles or all of them. And basically, we have to just define the paper format. I will have this A3 paper format. So the height of the paper is 29.7 centimeters. And basically, we can just click on draw. And the software is automatically drawing this helping red rectangles, which are basically created based on two criteria. One is maximum paper height, and the other one is maximum paper width. And now that these helping frames are created, we can easily go to function for plotting to layout. We can select again all profiles or just some of them. I will select just these two, and I will plot this to layout one, where I have the paper already prepared. So let's just create layouts. And now in a matter of seconds, we will see how this looks like, and it is ready to be plotted on your plotter or to PDF. So let's check it. A1, which is splitted into two papers because it couldn't fit on just one paper, and H1 is perfectly fitted on one paper. And for the final part of this webinar, let's export this to Navisworks. So to do that, I will switch to our BIM panel, where we have our functions for import and export to various BIM file formats like IFC, Navisworks, and LandXML. When we talk about BIM, building information modeling, it's not just about exporting the 3D solid elements. It's also the data that describes those elements that is really important. That's why in Urbano, we can create these data configurations, these groups. I previously created one geometry data, excavation data, sewage and water hydraulic data groups. And you can create these groups once and use them on all of your other projects. So let's now go to Navisworks export, but it is completely the same for IFC export as well. You have to define what you would like to export. So we will export this system and this Civil 3D DTM with all these data groups. So geometry data, excavation data, and water hydraulic data. And additionally for Navisworks, we can automatically create Navisworks selection sets according to any Urbano data. So I will create it by pipe material and pipe nominal diameter. And let's click right. And in a matter of seconds, Navisworks NWC file is created. So let's now check it in Navisworks. This is how it looks like. So you know that in Navisworks, it's really easy to navigate through your model. So we can check everything. So this is the Civil 3D DTM surface that I will hide. So we can focus on Urbano pipes and manholes. So if I select, for example, this pipe and go to properties dialog, we can check all these data groups. So geometry data, excavation data, water hydraulic data. So even in our BIM model, we can see this hydraulic data calculated with Urbano and EPANET. And the same is for the manhole. For example, again, water hydraulic data, excavation data, and geometry data groups. And also, if you remember, I also exported those Navisworks selection sets. So let's open the sets dialog in Navisworks. Let's also open this selection inspector so we can check the data. And now we see one selection set is according to material, which is just one material. All pipes are PEHD. But if we check nominal diameters, you can see pipes of 110, 125, 140, 160, 180, and so on. And in the data table, you can see the same data as in Urbano. Okay, so with this, we conclude this presentation, this webinar. I hope you liked it. I hope you would like to test it and try it on your own projects. And now, before we go to Q&A, I will give a final word back to Michael. Thank you all.
Thank you, Rino, for the great presentation. So before we finish, I just want to add a few words. As I said in the beginning, Studio Ars has been developing the Urbano software for storm and sanitary sewage, water, gas, and vacuum system design for more than 30 years now. We have an international presence. We have a partner channel that does a lot of the sales and technical support and helps our customers. Urbano software is available in more than 10 language versions, and while most of our users are in Europe, we have users on all continents. I would also take this opportunity to introduce the next webinar, the next live stream. So it's a Q&A session called Ask Me Anything about Urbano software, and it's scheduled for December 15th at 11 Central European Time. You can find event links on LinkedIn, on our company page on LinkedIn, and also on our YouTube channel, where you can set a reminder, so you can go there and register for this event. And also our next big live event where we will be showing the software again will be in January next year. So it's called the Urbano Software Deep Dive. So it's a bit different than today's event. We will not be showing an overall workflow. Instead, we will take one function and we will discuss it in much more detail. So for the first deep dive live stream, we will talk about shapefile import from various sources, various pipe networks. We will import into Urbano, and we will show you how you can do this import, how to clean up data, how to use it for design and calculation, and finally how to export it further so you can create a full workflow. So this next live event is also in the events on our LinkedIn company page and as well on our YouTube channel. So January 26th, again at 11 o'clock Central European Time, you find this event already on our LinkedIn page and YouTube channel, so you can go and register now. And this brings us to the end of today's webinar. Thank you very much for joining us. I hope you found the webinar useful. Please follow all of our news with the hashtag Urbano Software. Also, you will find our website, studioars.com. There is a newsletter you can sign on to. We have a Go to Stage channel where you can watch all of our previous webinars. Also, as mentioned, a LinkedIn company page with all of the live streams we are doing, and also a YouTube page with all of the live streams and also many additional videos. If you want to contact us, you can write to me directly. So it's my email is on the screen, michael.vaic@studioars.hr. Okay, And so now in the end, if you have any more questions, you can of course write them into the chat. I will just take a moment as we are streaming this on multiple channels. I will just take a moment to answer a few questions and also some questions that came in before. The first question was regarding actually this recording. So this is now recorded, and it will stay both on the YouTube channel under the past live streams and on the LinkedIn channel. I think it's in videos. So if you miss something, you can find it there, and also on our Go to Stage channel. It's right on top. Okay, so this is the first thing. The second question we got was regarding Google Maps import. So the question was, is it already available in the current version? So yes, we have been showing the current version in this live stream. So it's not some future build. It's the current 10.2 version, but these advanced data import and export features are not available in the standard version, but in the Pro or Ultimate version of Urbano Hydra and Urbano software in general. So EPANET IMP import export is available in the standard version, but Google Maps import, IFC export, shapefile import export, database import export, all of these, let's say, more advanced import export are available in the higher versions, so in the Pro and in the Ultimate version. Also, one thing that's available in this Pro and Ultimate version is a connection with Civil 3D, so either directly or through LandXML, but this connection only works for pipe networks, so what Civil 3D calls gravitational pipe networks. So unfortunately for pressurized systems, we can only export them as gravitational networks, not as pressurized systems for Civil 3D, and the main reason is the connection is not really good, so we didn't make it so far. Okay, let's see the next question. And by the way, if you have any question, you can type it in the chat. So let's see. The next question is about clashing. So do we have clashing? Yes. So we didn't show it today, but Urbano features a quite good clashing system. So it is a clashing system that is fully automatic by default. So when you design, immediately the system is checked for clashes, and actually these clashes will appear in your long sections, in your labels, on the plan view. So everything is automatic. It is also dynamic, meaning if you make some changes to your network, for example, if you move a node, this will automatically reflect in the plans and also in the long sections. So it is automatic, it is dynamic, and it is also 3D. So we take the pipes as with full diameter as 3D elements, 3D solids. Um, and also the manholes as well, like as 3D elements, and we check pipe manhole and manhole for clashes. So it's automatic, it's dynamic, it's full 3D. Um, uh, so essentially, it's quite easy to use because of this. You don't have to think too much about it. You can set it up once if you want to make some changes to the defaults, and then essentially it just works. And you can use it with pipe network systems made in Urbano, or even you can use it on some pipe network systems that are represented by lines or polylines. You can adjust this a little bit, and then you can check for clashes. Okay. Okay. So there is a question how to find us on LinkedIn, YouTube, Go to Stage. So probably the easiest way is just to search for Urbano software. Uh, or another possibility, so for example, on LinkedIn, here's the direct link. So it's, /company/studios. Um, Essentially, you search for Urbano software or Studio Ars on LinkedIn, and you should find us. And on YouTube, the link is a little bit different. But again, if you search for Urbano software or Studio Ars, you should probably find us there. Okay. So I think that's it with the questions for today. So if you think of anything, you can write to me directly. So my email is on the screen, and ask me any question. We will be having a training next week. So if you are interested in that, please get in touch. Find me. Probably the best way is to find me on LinkedIn, or just write me an email. We have some places still available. So just get in touch about this. And also, anybody that wants to have a trial of the software can get a free trial. So again, get in touch with me. And also, if you are a student, or if you are a professor or teacher, there is an educational version. Again, the best thing to do is just to get in touch with me, and I will help you with the software, with the license, and with everything. Okay. So, thank you for your time, for joining us today. I hope to see you in 2 weeks, where we have this Q&A session, and also in our future live streams in January and beyond. So once again, thank you very much, and have a great day.